This logic explains the double slit experiment. This logic explains why speed of light is a constant. The most fundamental things in physics have no causal chain. They just are. Why are we here? What's the meaning of life? What's the point of this universe? Major paradigm shifts are not easy. You really have to lead people slowly through the logical process before the paradigm shift becomes apparent. After that, I didn't ask the question very much, is this real? I just asked the question, what's going on here? What are we doing? Why are we experiencing this phenomena? And I spent the next probably 35 years trying to answer those questions. And eventually, I thought I understood it well enough and had a theory together that explained all the data points that I started writing books. And that's the My Big Toe trilogy of books. That was published in 2002, in February. And since then, of course, I've learned more. And one of the interesting things is that I wrote those books as an explanation of consciousness. It was a theory of consciousness, and that's what they were about. After I was done with them, had them published, they'd been out probably about a year or so, I realized that the very same concepts, the very same logic that explained consciousness also explained physics. And I didn't write them to explain physics, but they did. And then I realized, well, look at this. This logic explains the double slit experiment. This logic explains why speed of light is a constant. These are two big problems in physics. One of them, the double slit experiment, ends up with the conclusion that particles aren't really particles, really massive particles, they're probability distributions, because unless you consider them to be probability distributions, you can't calculate any right answers. But if you consider them to be probability distributions, then you can predict what these particles are going to do. But nobody had an idea why they should be probability distributions. With the speed of light, that's the basis of relativity. So the two big things in science had these problems of explanation in them. The probability distribution's totally unknown. We just know if we use it, it works. And in relativity, it was, why is the speed of light a constant? Everything else in our reality, it's the speed with which it moves is relative to the speed with which the platform that it's on moves. In other words, if you're in a car that's going 10 miles an hour and you reach out the window with a ball and throw it in the forward direction of the car 10 miles an hour, the ball is going 20 miles an hour because it's got 10 from the car and 10 from your throw. They're additive. Light isn't like that. It doesn't matter how fast the platform is, where the light source is, light always travels the same velocity. Nothing else in the universe does that. And it's a big mystery. Why should that be that way? Well, I realized that my theory of consciousness explained both of those things. Then I started thinking a little more about it, and it explained lots of other scientific problems. We have a scientific problem with the universe is expanding. It's not only expanding, the expansion is accelerating. And the question is, well, if our universe is all the reality that there is, this universe is all reality, then what is it that we're expanding into? How do we expand into nothing? Where does all the extra space come from? What's manufacturing the extra space that fills up the bigger volume as it grows? And there's lots of these kinds of questions that can't be answered. And there's questions like, where does mass, charge, space, time, spin, gravity, where do these things come from? These are all fundamental things in physics. And all of physics is based on understanding the interactions of them. But all of these fundamental things have no source. They have no causal connection. They have no causal chain. What makes mass? What makes charge? Well, we can break charge down. We can say an electron's charge comes from quarks. But what makes charge on quarks? You see, well, nobody knows. So the most fundamental things in physics have no causal chain. They just are. Same with the Big Bang. Where did that ball of plasma come from that went bang? And then evolution of the universe will tell you about how that plasma expanded, it cooled, suns formed, planets formed, and we end up with our solar system and us and so on, and it just evolved out of this universe. But where did that ball of plasma come from? Certainly didn't come from our universe, because our universe didn't exist. And why was that ball of plasma just sitting there with all that temperature and pressure, and how did it get there, and what was containing all of that? Because then at t = 0, it explodes, bang, right? It expands because it's very high pressure, very high temperature. But how did it just get there and sit there and wait for t to be 0? You see, so we have all these problems in physics, all these paradoxes that just don't have answers. And this theory of consciousness answered every one of them logically and with no added hard problems, no added assumptions. There's just two assumptions in it: consciousness exists and evolution exists. Everything else is a logical derivation. So I was surprised. You know, I'm a physicist. If I hadn't been a physicist, I wouldn't have noticed the connections. But I noticed the connections, and it surprised me. And then I started to think about more of it, things like tunneling, lots of these paradoxes in physics, and it could answer all of them. And then I started to realize that it answered other kinds of paradoxes too. Paradoxes in philosophy. You know, why are we here? What's the meaning of life? What's the point of this universe? You know, does it have a purpose? Do we have a purpose, or is it all just random stuff and we just happen to be here and there is no purpose? What's the cause of time? Where does time come from? It's another one of these basic things that, well, it just is. So it turned out that science is based on a lot of things that we don't understand at the root of it, which doesn't really give you a warm feeling about, you know, what we end up with. If at the roots it's like, we don't know, it just exists, then maybe a lot of the rest of the conclusions we're going to are suspect as well. So that's kind of how, you know, that's kind of how a nice physicist like me ended up in a place like this, you know, talking about consciousness and the larger reality frame. So I did get an understanding of it, and it does work, and it connects all the dots. As far as I know, I keep looking for dots that are disconnected, and every once in a while, somebody will point something out like that, and if I think about it a little bit, then I see how it just fits right into the theory. The nice thing is that it's simple. It's not that difficult. Now, it takes a long time to derive all this logically. We'd need to talk for probably 8 or 10 hours for me to give you logical derivations of this. But once you get it, and that's only because it would take you that long to get through the paradigm shifts that are required. Once you get through the paradigm shifts, everything becomes simple. It's really easy. But major paradigm shifts are not easy. You really have to lead people slowly through the logical process before the paradigm shift becomes apparent. Yes, well, just from our culture, we learned that physical reality is fundamental. Everything else is derivative from physical reality. Nobody set us down and made us memorize that, but we all just get that that's the way it is, and it's very hard to think in any other terms. It turns out that reality is not, our physical reality is not fundamental, that our physical reality is virtual. And back in 2002, when these were published, myself and Dr. Edward Fredkin, another physicist, and a few other people were about the only ones that I could find anywhere on the internet that thought virtual reality was a good idea, was correct. That was just a little more than a decade ago. Today, virtual reality, and by that I mean that our universe is based on information. It's information-based. It's calculated. That means it's a simulation. That means it's a virtual reality. So that's what we mean by virtual reality. It's a computed universe, and information is really at the base of it all. It's like a game. It's like World of Warcraft or The Sims. It's a virtual reality game. Well, if you have a game, you need to have a purpose. You don't just make a game for no reason. And you have to have, a process that works the game. And my theory of consciousness then explains the game and how it came to be, why it had to be the way it is, because it's not just that I make up this thing about a game, but I start with my two assumptions, consciousness and evolution. Everything else is, like I say, it's a logical derivation. So the purpose of the game has to be, this purpose, otherwise the whole logic, doesn't work. And the process has to be the way it is because it's just the outcome of a logical process. So none of this is introducing any new strange assumptions, no new hard problems, no new paradoxes are created. It just basically answers the mail. So that's sort of what I've done and where I come, what I came from, where I came from, why I'm talking about virtual reality. And I've just finished with a workshop here. Had about 80 people in it, something like that. And most people come in with the idea, this is really weird, this is strange, but I'm interested. Because they're interested in the nature of reality and how reality works and what's their part in it and what they should do to play the game better. And usually by the time I get to the end, and I'm mainly telling them logical process, almost everybody gets it. So it's not that hard. You don't need a degree in science to get this. And that makes sense to me because if you really understand a fundamental solution, you should be able to explain it to anybody. Any reasonably intelligent person ought to be able to get it. If you need to be a mathematician or a physicist, if you need 5 pages of mathematics to explain it, then it's probably not fundamental. I mean, it may still be true, but it's not fundamental. Fundamental things have to be straightforward. They have to be rather simple because they're big conceptual things at the fundamental level. Now, these fundamentals can go together to make all kinds of complicated stuff that needs 4 pages of mathematics to explain it. But the very fundamental things at the beginning are straightforward, simple, basic things. And they're not that hard to get once you can get the paradigm shifts. The big paradigm shift is that this is a virtual reality. Today, probably 20-30% of the physicists think that's a good idea because their experiments are forcing them to think that's a good idea. They do experiments now at the CERN experiment where they were, looking at the hadron, what do they call it, the God particle, Higgs boson. They were looking at the Higgs boson. And you can go to YouTube and listen to some of these scientists talk because a lot of them were interviewed because the Higgs was a real big deal, about a year back or so. A lot of news, a lot of interviews.
Validates quantum physics.
Yeah, and what you'll hear them saying is things like, we used to think of an electron as a piece of mass with charge, but we don't talk about it like that anymore. Now we talk about an electron as a point with the attributes of mass and the attributes of charge. Well, if you're going to simulate an electron in a computer, you simulate it as a point with the attributes of mass and the attributes of charge. They're having to approach physics as a virtual reality. It's based on information, attributes of information, not on a materialistic viewpoint of mass and space and so on. Space is a computation. And you find out, when you look at quantum mechanics, you realize that the fundamental thing at the root there that makes the difference, it's information. Information's the key. So modern physics experiments are dragging the theory into virtual reality. That's where the answers are. That's what you have to understand if you're going to understand the results of the experiments. So it's gone from nobody takes it seriously to a real serious concept within physics departments everywhere. See, so that's good. That's good for me because that is the way this reality works.